In this lesson, we're going to continue to examine our idea of combinations. We're going to look at some situations that involve combinations. We'll start with a typical question. Okay? We'll do most examples today. So we have Lisa. In her college program next year, she has to take 5 classes. She can choose from her 5 science courses, 3 math courses, 4 language courses, and 5 business courses. I want to know how many different programs, so selection of courses, she can take if there are no restrictions. Now this is a combination question because the order that she takes the classes and that she picks them doesn't matter. She can pick a math, then a science, then a business, or business, math, and science. Those are independent of one another. So because there's no restrictions, if we add up each of the classes, so 5 science, 3 math, 4 language, and 5 business, she has a total of 17 to choose from, and she needs to choose 5 of them. Okay, order does not matter. She ends up with 6,188 different choices. If we start adding some restrictions in, so for instance, at least 2 science courses, we're at the idea of making the chart. How many science courses could she take? Well, we have science and non-science, if you will. Okay, in terms of science courses, she has to take at least 2. So she could take 2, or 3, or 4, or 5. Now remember yesterday we talked about the idea of the indirect method. I could go through cases 2, 3, 4, or 5, or I could get rid of 0 or 1. I think it's faster to do these 2 cases than worry about the other 4. This is slower. Okay, this is faster. Now we're implying if she's taking 0 science courses, that she has 5 non-science courses. 1 science course implies 4 non-science, and she has to select these. There are 5 science courses to choose from, which means there are 12 non-science. 5, 12. Then we're going to multiply because we need to do both of those things. So if we do that, we can figure out each case separately. 792 and 2475. Right? 2 cases pretty quick to figure out. Now that's not our answer because our question asks us to figure out at least 2. So if I take my total, which is the no restrictions, and I say less than 2, I'm left with at least 2. So our total, when we start with 6,188, we get rid of these 2 cases that we're not allowed to have, 792 and 2475, and we're left with, let me stick that in there real quick. Oops, put a plus sign. I get 2921. And that's quicker. Now, on the note that I put on the website, I did the long way just to show you that it works also. But if we can, let's try and think of quick ways of solving these things when there's multiple cases to worry about. All right, one more. A maximum of 4 business courses. So again, we're at the situation where I have cases. Maximum 4 business courses. I've got business, and I've got non-business. How many businesses could I take? Well, I could take none, or 1, or 2, or 3, or 4. The only thing I'm not allowed to take is 5 business courses. So I could go through and add up all of these cases, or I could get rid of this one. So business courses. If I take 5, it implies I'm taking no non-business courses. How do I select my business courses? How many do we have to choose from? Well, there's 5 of them. So 5, choose 5 times, there's 12 non-business courses. This is a nice calculation. The answer is 1. So if I take my total minus more than 4 business courses, I'm left with a max of 4 business courses. Our total is 6188. There's 1 case where I took more than 4. So I know the answer is 6187. So that's kind of our standard typical question. It's like doing a committee question for combinations. But there's some other things we can do with these things. Combinations, that is. So sometimes we want to know the possible combinations of any size that can be chosen from a group of items. So I don't necessarily want to pick 5 classes for my program next year. Maybe I want to pick as many classes as I want to. 1 or 2 or 3 or 4 or 5 or 12, I don't know. Okay? And sometimes some of these classes may be identical. I can't tell them apart. Well, in these situations, we have to approach them in a slightly different way. We can do this by looking at an example. We have Josh. He arrived at a garage sale to find only 3 items left. How many different purchases could he make? So he could walk over and he could pick up the first item. Hey, I want to buy that one. So I'm going to buy 1 item. He's got 3 of them to choose from. He picks 1 item. Now let's write this down this way. 1 item. Or he could have bought 2 items. Well, if he does that, he's got 3 choose 2 ways of doing it. Or he could have bought all 3 items, which is 3 choose 3. And because these are separate cases, we know we can add them together. And if we do that, we end up with 3 plus 3 plus 1 makes 7. There's 7 different combinations when he doesn't say specifically how many different choices he makes. But what if we take this idea the next step? What if instead of arriving at the garage sale late, he arrives early? He arrives there and he sees 100 different items. Do I really want to go through and say 100 choose 1 item, or 100 choose 2 items, or 100 choose 3 items, or all the way up to 100 choose 100? That's going to be kind of time consuming, I'm guessing. So let's take this idea and think about it in a slightly different way. What if, when he gets to that garage sale late, he looks at the items, he says to himself, I can select or not select that item. In other words, I can buy it or not. I could take it or leave it. Well, if he does that, then really he has 2 choices for that stage of the problem. He looks at the next time at the garage sale, and again, I'm going to take it or leave it. I've got 2 choices for that stage. And same thing for the third. So in other words, he has stages, the first item, and the second item, and the third item. We're back to basic multiplying. But notice that answer gives us a different answer. Because there's something we didn't think about if he takes the option of buy it or not in each of those cases. What's happened there is, what about the case where he didn't buy the first item, and he didn't buy the second item, and he didn't buy the third item? Well, that didn't come into play on this page. We didn't have the option of 3 choose 0. We said he had to make a purchase. But when we do this idea of choices, first choice, second choice, third choice, that does come into play. So at the end, what he really needs to do to include at least 1 item is he has to subtract the case where he didn't buy something. Okay, there's 1 case. This is no purchases. Now, again, this isn't complicated 2 times 2 times 2 times 2 times 2, but we can do it in a slightly faster way. We can take that and think of it as small groups. Okay? The choice of take it or leave it, there's 2 choices, happens n times. So in other words, if I was thinking about the choice of I have 100 items at that garage sale, I can take it or leave it, take it or leave it, take it or leave it 100 times. That's way faster than all those 2s. But if I have to make a purchase, I have to get rid of the 1 case where I said, nope, leave that one, leave that one, leave that one, leave that one, over and over again. Okay, and that's way faster than going through and saying 100 choose 1, 100 choose 2, 100 choose 3, 100 choose 4, all the way up to 100, right? We don't want to do that. Okay, let's look at some situations where this is going to come into play. So, how many different sums of money can be made from a loonie, a toonie, a 5, and a 10? So a sum of money. A sum of money means I have some money in my hand. It could be a 1 and a 2. It could be a 10 and a 5. It could be a 2 and a 10. Any combination. In other words, I have the choice of using the loonie or not, using the toonie or not, the 5 or not, the 10 or not. So I have 2 choices for each of those 4 items. In other words, 2 to the 4. But if I say I'm not using the loonie, I'm not using the toonie, the 5 or the 10, I don't have a sum of money. I got nothing in my hands. So I have to subtract that 1 case, leaving me 15 different combinations of money. And now if you didn't like that, you also could have done, what is 4? Choose 1, plus 4, choose 2, plus 4, choose 3, plus 4, choose 4. That'll work out the same way. It's just a lot more math. Yeah, let's look at the next example. In how many ways can a committee be formed from a board of directors with 5 members, if at least one member must be appointed? So, a committee question. We've done these before, but the difference in this kind of question is it doesn't say a committee of 3 people. It doesn't say a committee of 9 people. It just says a committee. It doesn't tell us the size of the committee. That's what allows me to use this take it or leave it idea. I got to go through all the different combinations. A committee of 1, plus a committee of 2, plus a committee of 3, 4, 5. But it's faster to say to ourselves, hey, you're on it or not. You're on it or not for each of the 5 people. But if nobody's on it, we don't really have a committee. That's not going to make sense. So we have to get rid of the 1 case. And we get 31. Okay, last one. I want to give you some time to work on some questions today. Take some practice. We have a theme park. It has a variety of rides. There's 7 roller coasters, 4 water rides, and 9 story rides. Robin wants to try 1 of each type of ride. How many different combinations can she choose? It tells us here in the question it's a combination. Order doesn't matter. How many can she choose? Now you got to be careful here. We're told specifically she wants to try 1 of each type. So it's not like, oh, I'm going to ride it or not, ride it or not. I have to ride a roller coaster. There's 7 of them, and I need to take 1 of them. So I got to choose a roller coaster. And I have to choose a water ride. Well, there's 4 of them, and I got to choose 1. And she's got to take a story ride, and there are 9 of them. So I don't have the choice of take it or leave it. I have to choose 1 in each case. And so this is a basic counting question, a basic combination question. We multiply those 3 things together, and we should get 252. Okay, so the trick here, telling these 2 things apart, does it tell you specifically how many things you have to take? Or do you get the option of you choose the size of the group? If you're told specifically, you're doing the question like we just did, this combination where it tells us specifically. If not, we're going back to this idea, 2 to the power of, because I have take it or leave it for each case. Okay, some questions to try. I want you to try these ones. The more practice we get, the easier it'll get. If you're stuck on them, come see me.